because you're going to need to do it. All right, so this particular lesson is all about the real stuff. What you go buy, what you order, what you may be called upon to understand on a set of plans. It's all the things that actually make the real stuff that a person has to choose. For example, if someone's designing something, they may have this sketch of how they want to frame this clock tower up or something of that nature. Let's say we're doing this. But then they actually have to go order what type of steel, or actually choose steel parts and sizes based on what's available. Right? We can't just wing it. We have to actually stay in size. So if my design calculations say I need a W12 by 72.4, is that likely to actually be something I can buy? No, it's not. I'm going to have to choose something that is in the range of what I'm after. So finding the materials and understanding the shapes is the big deal. So if someone wants you to weld up a C-channel, what kind of options for C-channel are there? Anybody ever dealt with C-channel before? Anybody weld on some C-channel? Yeah, give me some sizes. Well, okay, so they do have a base measurement that is, and this is always the crucial dimension when dealing with like large steel objects or steel parts. W-beams, I-beams, channels, it's all about what the depth is, all right? So a very common size is a C6. Right? It means it is 6 units in depth. Now, is it exactly 6? It'll be a little plus or minus in there, yes, and maybe a slight differential, that's okay. But for the most part, 6 inches is pretty close. And it's going to be a call out of C6 by something. What do you think goes in this section of the call out? You would think that we're going to be dealing with actual stuff that deals with that. But let's actually Google and see what happens. Let's say steel channel C6 size, or C6. All right. Look, we've got one right here. It says a C6 8x2 hashtag, aka the pound symbol we used to know it as. What do you think that 8.2 means? Do you think that 8.2 actually means that this thing is 8.2 wide?
No, probably.
Well, that's a good question. What kind of value of thickness would be 8.2, you think? Possibly. But does it make sense for them to be switching units? Be going from inches to millimeters? All right, we already have the height. That's the 6. Well, that would be the next question, but this is taller, though. You couldn't have this possibly be taller than the outside value. So that 6 is right here. So right now, we found this one. It's like C6 by 8.2. So we're trying to figure out what this 8.2 really stands for. And the clue is this. Steel is always priced primarily on what measurement value? Weight. So what do you think? What perhaps could this 8.2 hashtag?
Oh, 8.2 pounds.
Pounds per foot. Foot. Yes, this means the pounds symbol. So when I go order a C6 channel, 8.2 means it for every length of channel, it is 8.2 pounds. So for a quick bit of math, if I buy a piece of channel, or if I go look at a set of plans that has a piece of channel on it that shows it as being 10 foot long, and I'm buying a C6 8.2, how much is it going to weigh? So it would be 8.2 times 82 pounds. Yep. I like to use those nice round 10 numbers, makes it easy for calculations. But that is one of the key things you want to look at in a set of plans. Because on a set of plans, if you might be doing some fabrication for a steel frame system, maybe you're doing fabrication for installing some big machinery in a company in your plant, mechanical drawings or structural drawings, doesn't make a difference. You're probably going to run across this at some point in time. And you have to understand how the stuff's priced so that you figure out how much stuff's going to weigh. For example, you're making a big Haas system that's made out of a bunch of W12 by 22 pieces, all that weight starts to add up. So you got to use the plans to tell you how long this stuff is, and the plans to identify what the parts are, and figure out what your total weight is. Does that make sense so far? All right. So let's do some research. Throw on our Googling skills. We actually have this thing called American Standard Steel Channels Engineering Toolbox. Great little place to look up some stuff. It's got all kinds of things. Look at this. Inch. It tells you this is the height. That's your C value. So a C channel that is C15 by 40 weighs how many pounds per foot? 40. So if I actually have a 10-foot span I'm using it, it's obviously going to be 400 pounds. It's a lot of weight, right? And another reason why you need to understand this is because you might be the person putting this system in. You got to be thinking, do I need to go rent a jack system for this? Do I need to go rent a truck? Do I need to have 10 guys help me put this thing up? Because this kind of thing is the planning factor that matters in the blueprint side. You got to be thinking about your equipment. But look at our different sizes. We start scrolling down, and we see there's actually coming down, there's C5s, those are C6, there's a C6 8.2, there's a C6 10.5. I could mark these on the screen while I'm talking about them. There's these. I've got the C5s here, and the smaller I go, the lighter weight options I get. Now, if I'm looking and being honest with myself, I would really like to go with this C3 by 5 or even a 4.1 because that's only 4.1 pounds per foot. Probably something I might be able to handle if it's not too long. But you're going to notice that these sizes have different weight ratios. So they're all C6s here, but they range from 13 pounds per foot to 8.2 pounds per foot. And you can expect, examination material to reflect this particular topic. Homework assignments, those kind of things. I want to know that you have the ability to figure out these weights and understand what you're drawing or dealing with on a drawing so that you know how to plan. Because planning is a big part of figuring out how to make something, fabricating in any field or fashion. But that's just C channels. So let's back up. What about W-beams? W-beam dimensions, or maybe sizes. There's all kinds of stuff out there, and the engineering toolbox is usually one that gives us a lot of good information. But look at this. We've got W-beams that are 27 inches tall. Literally, this thing is over 2 feet in size, this cross section, in just the height. Man, that's a big piece of steel, right? But that's holding up a lot of buildings. Now, look how much they weigh. Look at the range of weights for this. 178 pounds per foot. So you just have a 10-foot span of this thing, which is very unlikely, because if you're going to have a beam that big, you're going to want to run it like 20 feet if you can. By the way, does anybody know roughly what steel comes in lengthwise, like some of the maximum lengths of steel that you can buy? I won't say maximum, but the most common lengths. About 30 feet. About 30 feet ordering is about the length, because that reflects, what kind of truck they can bring it on. They can bring it on bigger for sure, but when you order sticks of material, you're probably going to be looking at about 30 feet max length in terms of decent pricing. You start going over that, you get into custom stuff. And most people try to figure out what sizes do they need to order so they can get the most bang for the buck and have the least amount of leftover. But look how heavy that thing is. Even the most lightweight version of this 27-inch tall beam is 84 pounds per foot. So if you're putting this sucker up, you're thinking cranes and all kinds of stuff. But let's scroll down a little bit. It goes all the way down to W4s. So we go from this massive thing to one that's only 4 inches tall and weighs 13 pounds. So let's say it's a W4, that's a bad 4, W4 by 13. So every foot of this thing weighs 13 pounds. I could probably use this in maybe a basement or porch scenario and have a decent span without too much deflection, possibly. I could use this perhaps on some trailer stuff. I think we actually did use some W-beams on some stuff on a trailer system one time for some custom work. So you're thinking about that. You're figuring out how to put this stuff together. But keep in mind, it's only 4 inches tall. So if you want to weld in here or do something in this space, you're not going to have a lot of room to work with. But how wide is it, you wonder? Or at least I'm going to hope you're wondering. How wide is it? Well, we can look at this little toolbox, and it tells us here that the width is right there in that second column, and this W413 is actually 4 units wide. So it's just a hair taller than 4 and just almost right at 4 inches wide. So it's almost a 4x4 in equivalent design. How are we doing so far? Getting the hang of this? It is all out there. There are tons of charts and everything. Most steel companies want you to have this information. They want it to be convenient so they can sell it to you. So they're going to give you everything they possibly can off of their website. However, the AISC, American Institute for Steel Construction, technically is the one that officially produces most of the manuals that everybody else bases their stuff off of. Also, the ASTM generates a lot of stuff. But it's no big deal. You can find this data in no time flat. In fact, there's apps you can get for free that actually have all these charts ready to go for you. So if you ever need to know a size on a set of plans, you can do this. But there's a lot of different steel shapes. Let's think of some of them. You've got your W-beams. You've got your channels. So you got a W, a C. There's actually another version of a channel called an MC. There are this version. What's this right here? What's this cross section? What would I buy out of steel that's shaped like this? A pipe. You've got your square-ish tube. You've got your rectangular tube. By the way, these things come in different grades. You've got versions that are what we call high-strength steel. And you've got your standard A36 steel. This one's closer to 50 though, 40 or 50. So you got different versions of that. Their sizes are about the same, but their strength values are different. So you got pipes, you got steel tubes, you got rectangular tubes, you got channels, and these are some of the most common. There's some other shapes beyond this, but you can look into them as they rise. By the way, if I go order a steel pipe, let's say I go order a 6-inch steel pipe, is there, and I'm going to use it to flow some, we're going to pump gasoline in this 6-inch steel pipe across America, okay? That's our game plan. 6-inch steel pipe pumping gasoline. So what do you want to go with? You want to go normal wall thickness or extra thick? We're going to go extra thick, right? We don't blow this thing up. But how do you call that out? Well, the pipe system, like if you were going to call thickness out here, you actually have to go pick out what's thicker. You have to base it on whatever size they have. But pipes actually come in various forms. So they come in like standard. So you go say 6-inch pipe, that's going to be your standard wall thickness. Then you've got an XS, which is extra strong. And then you got a double XS, which is what, as you might imply, double extra strong. Let's check it out. So let's go up to a little toolbox here, and let's go steel pipe thicknesses. And let's see what we got here. Actually, let's just do steel pipe XS. And so you can find out that you got extra strong, the XS version, and then we try a double. And then we got our double size. So you can go find out, I don't remember, these are actually schedule values. It's like schedule 40, schedule 60, schedule 80, those kind of things. So you can actually find that out if you need to, but just be aware they call wall thickness out based on these kind of little add-ons. Now, here's your next question. If I'm going and buying a 6-inch steel pipe, but I order extra wall thickness, where's the 6 inches? Is it on the inside diameter? Is it on the outside diameter? Any ideas? Always an easy way to tell. You can Google it. I'll let you go figure it out. But keep in mind, you have to be, and this is where people go wrong a lot of times, they a lot of times make mistakes on if they're dealing with ID or OD.
I was going to say, you have to know that.
You do have to know that. And actually, different groups of designers operate in different logics, okay? So if I'm a hydraulics person and I'm worried about fluid flow and internal friction and all this stuff, and you think I'm more concerned about the inside of the pipe or the outside of the pipe? Inside the pipe, absolutely. So I'm all concerned about the ID. If I'm the civil guy who's worried about the pressure on the walls and actually driving on this thing with 2 or 3 trucks, or if I'm the structural guy worrying about the building, I'm going to use steel pipes as the building structure. to actually how this is going to look in our buildings. Next time you're at a gas station, look at these columns that are holding up your roof system over top of your head when you're pumping your gas. They're going to be basically steel systems, but they may be massive steel pipes or massive steel tube. But that's straight up what they just buy and just use it for steel framing. So I'm going to be concerned about OD in that scenario because I may be more interested in the overall look. It matters in different fields, so as you all are doing the fabrication and worried about the prints, you need to be checking that too. Am I dealing with ID or OD? And the charts will always tell you, so you got to go to that. So a lot of things to consider when you're going through this kind of work. What kind of part size, what's available, how much is the thing going to weigh? Because that's going to matter a whole lot to whether or not you can fabricate it. We were doing some work on a clock tower at one point in time, and it was a matter of deciding if they were going to be willing to do a big steel tube system that was or actually it was like thin wall, or a slightly smaller tube steel with super thick wall. Problem was the clock tower was so tall it had a deflection issue. It was actually bending too much. It was holding up, it wasn't failing, but it was bending too much to meet code, theoretically, in design. So we were telling them, okay, do you want a thin big tube or you want a thin or smaller tube? And they have to make the decision based on all the other plans and clearances and stuff like that. Big deal in decision making. Questions so far? All right, good stopping point. We'll cut off right there.